Okay, continuing from where we left off, we're going to finish finding the offset voltage. So we had an expression VOS was equal to VTH1 plus square root of 2ID1 over Kn times W over L1 minus VTH2 minus square root of 2ID2 divided by Kn times W over L2. Alright, so we're going to substitute our mismatch parameters into this equation, and we can write that VOS is equal to delta VTH plus square root of 2 times ID plus delta ID over 2 divided by Kn times W over L plus 1/2 delta W over L minus square root of 2 times ID minus delta ID over 2 divided by Kn times W over L minus 1/2 delta W over L. After a little bit of algebraic manipulation, we could show that this was equal to VOS is equal to delta VTH plus a VGS minus a VTH times square root of 1 plus delta ID over 2 divided by 1 plus 1/2 delta W over L over W over L minus square root of 1 minus delta ID over 2 divided by 1 minus 1/2 delta W over L over W over L. Alright, so we're going to use the binomial theorem to simplify this expression. And what this says is if we have a polynomial raised to a power, 1 plus n to the x, raised to the power m, for instance, if n is small, then this is approximately equal to 1 plus m times n times x. Now hopefully n is small because we're talking about mismatch parameters here, so we're talking about delta terms and we would like these to be small. And if we use this theorem, we can now do a little bit of algebra and say VOS is equal to delta VTH plus VGS minus VTH times 1 plus 1/4 delta ID over ID times 1 minus 1/4 times delta W over L over W over L minus, we're going to continue on the next line here, 1/4 or 1 minus 1/4 times delta ID over ID times 1 plus 1/4 delta W over L over W over L. Now we're going to multiply these terms out and eliminate all of the small terms, and we would find an expression that was VOS is equal to delta VTH plus 1/2 VGS minus VTH times delta ID over ID minus delta W over L over W over L. Now looking at this expression, and noting that when VID is equal to VOS, VOD is equal to 0, this would suggest that the current flowing through the product of the current flowing through the resistor in each branch would have to be equal. In other words, ID1 would have to times RD1 would have to be equal to ID2 times RD2. So we could say that delta ID over ID is equal to minus delta RD over RD. One final substitution says that VOS is equal to delta VTH plus 1/2 VGS minus VTH times minus delta RD over RD minus delta W over L over W over L. So, looking at this, we want to be able to draw some conclusions about how we can improve the offset voltage in our transistor. In other words, make the offset voltage go to 0. And what we can see immediately is that if we make RD or the size of the transistor bigger, it minimizes the offset. This kind of analysis is helpful in letting us know as designers what we want to do in order to improve our designs. Now, note we can't do anything about delta VTH. This is something that the process designers have to control, so they need to control their process very tightly, and if they do, then delta VTH would naturally be small. But as designers, assuming that they don't control VTH very well, we know that making RD or W over L of the transistors bigger minimizes the mismatch.